Aloha, Richard Halverson here. This is ITS128, and it's second of the last week of the semester. And so I'm gonna go over, I guess I'm just gonna do some wrap-up stuff, tell you where everything is. There's not gonna be a final. You just have to do everything in Zybooks. So let me share my screen. All right, so we are, what's this? So through 128. And so we are at the end here. And so there's not going to be a final. I put final there because sometimes they tell you should have a final, the folks up above, and sometimes they don't. So I don't like those pressure kind of situations. So if I were to give a final, I would just take some of the lab activities, probably the lab activities, and I'd just assign them at the end and call those the final. But anyway, so we don't have to do that. So you have you have finals week to get all of your Zybooks assignments in. And on my grades are due probably like we're going to start getting emails pretty soon. This is the last week of classes, and this is finals week. So grades are due probably the 18th of May. I don't think they're due the 11th. No, they wouldn't be. They're due the 18th of May. And so since this is all auto graded, I just download scores. And so my deadlines are I would like to make my deadlines, your deadlines reasonable. So we work backwards, and I don't want to have to give you artificial deadlines like, oh, you got to have it all done by the first week of finals, because what am I going to do between Monday the 10th and Monday the 17th? Well, I'll tell you what I'll be doing. I'll be handling requests from people saying, oh, can I just have a little bit more time? I'm almost done. And the soft-hearted person I am, I say, well, okay, my grades really aren't due till the 18th. And then all of a sudden I've given one person a special favor that I didn't give to everybody else. So in the past, what I would do is I would make an announcement, say, okay, well, we change of plans here. Grades are due, it's extended deadline, and that got to be kind of silly. So I just decided, now I'm just gonna, your deadline is my deadline, and if you get it done past that, there wouldn't be anything I could do, because I already had to turn in my grades. If I don't turn in my grades the automated way, then they make you a KCC here. They make you fill out a change of grade for every student, and so I don't want to do that. So anyway, so let's go to Zybooks. So video 14 talked about 10.1 to 10.6. And I think I have posted video 15. Did I do something last week? I can't remember. I think I might have done something last week. So I have posted 15, which is chapter 11. The chapter 11 exercises. Let's see what it says here. Yeah, labs 8, 9, and 10. Aloha, Richard Halverson here. This is ITS128. And today is whatever. It is February 5th. And this is I recorded this earlier this semester for my 148 class, as you see. So you're getting more than they did. So I'm going to go here. I'm going to go back to that one, and I'm going to stop it because I don't want to hear my voice. And I'm going to do share, and I'm going to copy. Then I'm going to go back here and do edit. The details. Sorry to be taking up your time like this. All right, so that's there. And do I have a, oh, geez, I guess I should do, where's chapter 12? That's, okay, chapter 12, that's next week. That's kind of, chapter 12 is a good chapter because we actually read and write files. And then, and once you can read and write files, you can start doing, you know, much more useful stuff. You know, you can read in a file, read in a CSV file, like a spreadsheet, and you read it in and you can, you know, do some stuff. And so that'll be interesting to go over that. But and I'll do that next week. This is today is right. Okay. So but let's see if you go to I guess you go to resources and you go to fall 2020 videos. And I do have the, yeah, 12.9 and 12. Oh, I do have the labs here for chapter 12. So you do have videos. They might be older videos from fall, but videos to show how you, when you're doing these assignments, when you're doing these labs, if you really get stuck, you can go to the video and, you know, find on the screen where it's typing in the code or whatever, and you can go and figure out, you know, get some good hints to get it working there. And so why don't let's sign in. Let me sign in here. And why don't I talk about a little bit about modules. So the interactive Python interpreter provides the most basic way to make this bigger. And of course, what that is when you open up your, if you open up your command prompt, and I should show you how to do this on a Mac also. Yeah, maybe next week I'll show you how to do it on a Mac, because I have a setup. I've set up a Mac and Windows together because I gotta do some support for some Zoom support this weekend for a Zoom conference, and I've got to know how to do stuff both on a Mac and Windows. So I think maybe next week I'll demonstrate that, because if you aren't doing it already, and some of you who are here today, you know, may have done it already, but there's probably Mac users out there in this class that haven't really gotten this part, command prompt thing, running again, because it's a little tricky. You got to go in and you use the text edit app on the Mac, but there's no way to save it out as a .py file unless you go in and change some of the preferences. But the Mac has, you know, has Python in it, because there's a lot of the Mac operating system, a lot of the utilities and stuff are written in Python, so they actually have that there. But it's an older version of Python. It's Python 2, and in this class we're doing Python 3, and there's significant enough differences that it kind of matters. But what they're talking about here with the Python interpreter, of course, is you can just do. I have Python 2. If I just go Python, then I get into this interpreter where I can just type in Python commands, I equals 1, print I, and, you know, prints 1 kind of thing, Python interpreter, but it's version 2.7. But also, let's see, how do I get out of here? Exit. Okay, and then if my Python 3 is py, and there's Python 3, and so now I do things, I can do Python 3 the same way. But so thus the program, it's lost when the programmer closes the interpreter, of course. You know, that's, you know, you can type in stuff, you can type in modules, you can type in statements, and you can also type in a program, and as you're typing in it, it's going to be executing it, you know, with the interpreter. But when you create variables and create, you know, any kind of data structure, lists or dictionary or anything in the interpreter mode, you know, the interactive interpreter mode, you know, the data stays. You can access it in later statements. But then when you close the interpreter, of course, it's gone. And that's why we write scripts, and we execute a script like we would execute a program in a traditional programming environment where you have a compiler and an executable and so on. But anyway, that's not really what this is about. This is about modules. And so a programmer can find themselves writing the same function over and over again, as you know, and he finds it in the same, you end up typing in the same sort of scripts or functions in multiple scripts. And so what you can do is you can create a module, and that's got Python code, you know, in the form of a function, you know, where you have a definition statement. And then down here, you can call the functions that you created. And you can also have them, you know, if you have a file that's got a bunch of functions and you want to use those functions in some other program, you can just say, you know, well, let's here. In this case, in this example, we've got same function here and same functions here, and they're the same, but it's two different programs, script 1 and script 2. And what you can do instead is you can define a module called functions, but then you use this import funcs, you know, import that name into script 1 and script 2, and then you don't need this. You can just put this and then have the rest of your program here, and it knows what's going on. Now you do have to put this prefix thing here saying, I want to use the FCT function from the func you know, imported module here, imported module. And so you click down here and start, so you get the points. By the way, you guys should, let me just quick go back to here and go back to here and go to reporting. And I just want to see how the whole class is doing in general. Now these XiLabs here, these are the this is the whole class in general. In the green cog XiLabs column, that shows the progress of all the folks, all you guys, all you folks in the class, how much you've completed. And for all these ones, if you're having trouble, then you need to go to a video, and there's a video for every one of them. Okay. The video is either in fall, and it's in the resources folder. It's either in the fall 2020 folder or the spring 2021 folder. You know, or you click on the syllabus, the video link on the syllabus. Now okay, so the participation activities, everybody should just get all the points. Okay, if you end up getting a B, if you end up settling at a B, and there is participation activities that you didn't do, and that if you were to do, you'd get an A, then your priorities are different. You're so busy that you can't just go in and click around. And what I mean by that is you can just like, you know, I mean, anything. Let's go into here. Let's go into 67. Okay, people have only done 6. So there's some of you that haven't done these. And for this particular chapter, how do you do it? Well, you click on here and you do start. Here, let's do one that I haven't done. Okay. Making these points. Let's do this. Oh, whoa, we're in modules, and I haven't done all the modules, have I? So you just went over, I just went over this. Well, if you were watching me, you can just go see, there's no points. I haven't got any points yet. Just click and go fast. Go click start. Oh yeah, that's nice. Oh, you know, looking at something else, whatever. Click again. I'm being stupid here, but you should pay attention to this and watch what's going on, because when you pay attention and watch what's going on and understand what they're trying to show you, then it makes the challenge exercises much easier. It's just the same thing. And then when you get to the labs, you're just putting all that together. But anyway, so I've gotten all the points now. There it is, checkbox. And what's next? Oh, here again, okay, let's go through this. The module's file name should end in py, otherwise the interpreter will not know. A module name should match the file name of the module. That's the module name. They're talking about this FUNC and FUNCS, FUNCS. That's what they're saying. If a programmer wants to import a module whose file name is that, then you're going to put this in your program. Yeah, you don't put the PY. Note that the import statements are case sensitive. That means, you got to use, this is different than this. It's not that way in a lot of languages, but it is in Python. Interpreter must also be able to find the module. So the best thing to do is to keep it in the same directory. And so let's try to answer. The import statements should be at the top. They don't have to, but they should be. And if a module is required by another program, that's called a dependency. Okay, the program is dependent on the module, otherwise it won't run. So a programmer using the interactive interpreter wants to use a function named this, in a file named this, write the statement that imports that. Well, it's just something like import tools. I think that's right. We can check it and it's correct. But as you know, if my earlier point was, you should just make sure you get all the participation activity points. I mean, in fact, if I go in there and I see that you did all the you got all the maximum scores all the way across, and when I download the scores, especially participation, most everybody does all the participation scores. So they're all like 96, 90, whether they're all the same, except for there's a few stray lines there that they're not all the points there. And, those, there shouldn't be any of those because they're so easy. In fact, it's so easy, you say, a file containing Python code that is passed as input to the interpreter is called, I don't know, you can just click the show answer twice. I think you can do this on yours. If I'm not right, I don't think it's because I have the instructor version or whatever. But anyway, so yeah, the answer is script. Now you still have to go over here and type script. I wonder if you have to do you don't have to do uppercase, do you? Still have to do that to get the checkbox over here. So you put the right answer in there and you get the right answer. Is a file containing Python code that can be imported by a script, a module. All right, so evaluating an import statement initiates the following process. This is just to make sure you understand. Check is conducted to whether the module has already been imported. If it's already been imported, then it's not going to import it again. If it's not imported, a new module object is created and inserted into this area called Cis modules, system modules, and the code in the module is executed in the new module's object's namespace. So really all that has to happen is the module be executed, and then it's all ready. And then the program has got access to all of the functions that were available in the module. So when you're back up here, once this happens, then this is just executed. With this, when this happens, first it checks to see if it's been imported previously. And if it's not, then it just grabs this in there and executes it. And then that's just like that's like it's been executed up here, and then you're ready to go down here. So it's the same kind of thing. So, it doesn't have to be there for future reference. It has to be just executed. And the fact that it's executed, the execution of the module sets up all of the functions as, objects that are accessible by the program down here. All right, okay, so importing the module. So this shows how it works. We're importing web page. We're importing, first we import this, and then we import this. Okay, I think this is showing an example of when we import this, when we import this, we notice that inside this, we import web page. So web page gets imported when this thing is imported. So then when this thing executes, it's not going to execute because web page, well, it'll look at it and say, oh, we've already imported web page. So then it does not import it again. So that's what this shows. And so we can see first it executes that. Looks in system modules, HTTP server is not in there. So it connects, finds HTTP server.py out here, and it executes it. And as the first thing it does when it executes, it does is import. So it looks up here in system modules, there's no web page. So then it connects up with web page, and it's going to start executing that. So there's that going da. Oh yeah, all right. It executes this thing, and what this executing this thing does is it sort of activates and makes available the disp function. And then so now that it's all executed, web page is done being executed, and it's now available in HTTP server because that completes this execution of that right there, of the import web page. And so then it continues executing, executes away, and web pages. Oh, it comes down here. Yeah, so we're back in the main program. Web page has already been imported, so it doesn't have to be imported again. So anyway, so I get the checkbox there. All right, let's try this executing. Okay, causes a new module object to be created. Yes, it does. Okay, so order the events as they occur when the statement this executes, assuming this has not been imported previously. All right, so first thing that happens is this. First, it checks to see that if HTTP server is in there. Yes. And then it sees that it's not in there. So then it, gee, I don't know if this comes first or this comes first. I bet you this comes first. No. So it's not that one. It is. Oh, this one's probably down here. This one. No. Oh, this is next. I think. No. Must be down here then. This must be here. Well, I was really wrong. I was really wrong. But anyway, there's only a certain number of combinations, possibilities there. And so something like this is good because, you know, you never really, as you're going through here, it's not obvious by just absorbing this participation activity what the solution here is, and so you just try and do it and get it wrong a few times, and that sort of reinforces how it works. Okay, so first it checks to see if it's in Cis modules already. If it's in there already, then it doesn't need to do any of this stuff. It's not in there, so it has to create a module, and then it creates the module, and then it adds HTTP server to the Cis modules space up here, and then it actually executes the code. And once it's all executed, then it's added to the importer's namespace. It's added to this space down here. No. Just space. Let's see what happens when this runs again. Well, that's okay. You should be able to click through this and see that it is. I'm going to start over again. I should have done that. Okay, I'm going to try to, this is the one. I'm going to try to do this one again because I want to see first it's, first it checks to see if it's there. If it's not there, it creates a module, and then it's added to the Cis modules namespace, and then it's executed, and then it's added to the importer's namespace. Well, anyway, I'm not going to go through this again, but you should be able to verify that. Okay, so once a module has been imported, the program can access the definitions of the module. It's pretty obvious, yeah, but you got to prefix it with that so you know where it's coming from. So here's an example of where you can have a function like this, which is a factorial function, and factorial is, you know, 5 factorial is 5 times 4 times 3 times 2 times 1. And this is a, yeah, this is just an iterative factorial function. And down here, if this is in my function, my funcs, and then we import it, then we have access to the factorial function. We have to put that there. So anyway, this just shows that. Okay, consider a file shapes.py with the following contents. There's some, can draw a square, can draw a rectangle. The square, you take the size, and the rectangle, you take the height and the width. Complete the import statement for imports of shapes. So it'd be shapes, I think. And then complete the statement to call the draw square function from the shapes module, passing the argument of 3. Draw square, passing the argument of 3, would it be that? And write a statement that changes the output to use this when drawing shapes. So it tells you what you want to change that. So it would just be shapes.cr equals $, I think. All right. Okay, here's a challenge activity. And so enter the output of modules. So let's just start. And we get here, oh, we're supposed to write this. Okay. So first we import arithmetic, and arithmetic looks like that, which is you get a number and it multiplies it by 4. Calculate a number, returns the number times 4. So this is imported. Are we supposed to be figuring out that, oh, okay, got it. Oh, I see what this was up here then. We're supposed to see that there's a difference between, never mind. Okay, so so this, the first one is gonna do calculate of 1, which is gonna call this one. So it's gonna be times 4. Whereas when this one is done, it's just gonna be plus 4. So we have the first thing it's gonna print is the times 4. So that's 4 times 1 is 4. And then the next time it's gonna print 1 plus 4 is 5. See that? And what's the next one? I'll do the next one, then you can do the following 2. We've got 3 modules here. We got this arithmetic module, and that's subtracting 4 from the number. We've got a data module, which executes a bunch of assignment statements defining values for these variables. And then that's data, and this is arithmetic. So then we have this calculate function, which adds 5 to the number. So first of all is calculate data small. So this has been executed. This has been executed. So what is small? Small would be 8. Okay. So calculate, and it's this calculate, so it's this calculate. So it's add 5 to 8, and that is 13. The next one is I'm going to use the arithmetic calculate on the same number. What was the number again? It is 8. 8. What is how does calculate in arithmetic work again? It's subtract 4 from it. So what is 8? What is 8 minus 4 is 4. So this is going to be 4. Check. Very good. Okay, you can do the next one. We've got to execute the green first, defines some variables, then executes red, and that defines some more variables. Dark, bright, medium, dull. Dark, bright, medium, dull. Okay, it's different. It redefines, well, it defines another set of dark, bright, medium, and dull. And then here it's going to print whatever dark is in green, which is whatever that is, and then it'll print whatever dark was in red, that one. So that's how that one works. You can do that. Okay, finding modules. Importing a module begins a search to find the corresponding file on the computer system. The interpreter first checks for a matching built-in module. By matching built-in module, that means a built-in module like math. Import math. First, you don't want to have a module named math, because if you say import math, it's going to import the built-in module first, the one that is pre-installed with Python. Cis, time, and math are examples. If there is no matching built-in module, then it searches the list of directories in Cis Path, which is located module. And the programmer must be careful not to give a name to a module that is already used in a built-in module. So otherwise you won't get the one you want. So Cis Path is a variable initially containing the following directories. It's got the directory that the script is executing. It's going to look there first. And then there's a list of directories specified by this variable here. And then when you installed Python, that probably got a few directories got put in there. And at the very end, it actually looks in the directory where Python is installed. And so, for simple programs, a module might simply be placed in the same directory. But for larger programs that have bunches of modules and third-party modules, they'll be in different directories. And in those cases, you might want to add those to this second path thing here to defaults. An operating system environment variable is like a variable in the Python script, except for it's stored in the operating system and can be accessed by every Python program. And this Python path is such a variable. It's an environment variable. So if you put another path where some functions might be, some modules might be in a Python path, it's going to look something like this. It's going to look something. Python path is equal to it, and it's equal to this path and this path. So if you if you have import a module 1, the first it's going to look in to see if module 1 is a built-in module, and if not, it's going to look in the directory that the script that's executing. It's going to look in that directory, like ITS128 on my desktop. If it's not in there, then it's going to look in this directory. it's not in there, it's going to look in this directory. And if it's not there, it's going to look in the directory where Python is installed, which is down C drive or something. Interpreter immediately checks the current directory for a match. When an import statement executes, the interpreter immediately checks the current directory for a matching file. It does not. It checks for a built-in module first, I think. No, I'm sorry. It should be this one. Yes, okay. Python first checks built-in modules. See, even though I answered it wrong, I got all the points. The environment variable Python path can be set to specify optional directories where modules are located. Yes, that is true. MathPy is a good name for a new module. No, it is not, because there is already a built-in module called math. So it's not a good name. Okay, importing specific names. Okay, so you know how you have to put the name of the module dot the name of the function? Well, if you don't want to do it that way, you can just you can actually import the functions, and then you don't have to do that. But this is how you do it. You would say from a certain module, import these functions. So instead of having just an import at the top, you would have this at the top. So a normal import statement would be this, and then you can use all these functions, but you need to put that in front of it. But if you do use the other way, then you do this way, then you only need to use the name of the module. So let's see what this is showing us. Import my mod, puts that in the global namespace. This has got a function called, it's got a variable called x, which is equal to 55, and it's got another function called calc a, which is something it puts over there. Then what's next? Then it executes the 100, and then it executes this, which calls this, which calls this, which somehow calculates a z, puts that back in here. And then what happens? Oh, this is a different case, where in this case, the import is this. So then it goes right over there, and all it does is import calc space. X is not brought along. X is brought along in this case, but in the second case, it's not. So you see, you only have to do it that way instead of up here where you have to put the prefix, or you have to put the module name in front. That's pretty obvious. Okay. So import module, this is, you know that already. Using the keyword to import specific, using the from keyword to import specific names. And so this is how you, example of using that. Here is extending the hash example. Improve the hashing example from the above by adding a new algorithm. And then import that algorithm, import this. We're making a new algorithm. Is that the new algorithm we're making? What is SHA? Okay, so let's see what this is doing. Okay, so a hashing function is just where it takes some input and it hashes it to some output in some way, but it does it that way all the time. It's consistent. So so that way, if you have a hash function, and there should be like no obvious way to get you have a number or something. You have a number and you hash it into another number. It's hard where you have if you have the hash number, you can't get back to the original number. So it's good for passwords, because if you have a password like my cat's name is Pepper or
password. So say you have a password like that, and you put a hash function, you run it through a hash function. It's going to turn into some gibberish. But the fact is that it's going to turn into the same gibberish each time you put that password in. So if you just save the gibberish, if you save the result of the hash function, then you can tell if somebody gave you the right password. But they're not giving you the password. The system can tell if the person enters the right password because the system takes the password they entered, runs it through the hash function, and out comes the gibberish, and it's the same gibberish as was previously stored for that password. So then it knows the person typed in the same password, and you can still hide the password from them because you can just pass through the gibberish and not pass through the password. So anyway, so there's MD5 is a very common hash function. I guess SH1 maybe 1, 2, and what are we supposed to do? We're supposed to import a new one from hash. Oh, there must be another SHA224 function. Okay, so enter some text. Okay, so first I'm going to run and see what happens. Okay, so we enter in some text. Oh, and then we enter the algorithm. First, we enter the. This is so bad. Let me pull this up. Exit. CD. I don't desktop. No, I gotta go to the OneDrive. CD desktop. CD ITS128. And then I'm going to do. I'm going to use Visual Studio Code. Okay, code period. You can install Visual Studio Code. It's free. Python's in there, and I make you do that in 148. By the way, if you take 128 and you can sign up for 148 and 228 for fall. You sign up for both of them, and then you can kind of take them together. There's common crossover stuff. Like first we go over some algorithms that are not recursive, and then we do the same algorithms in recursive versions and so on. And if you actually sign up for 128 in the first half of the semester, 148 in the first half of the semester, and 228 in the second half of the semester, I hope that's what I said before, then you can actually start 228. You can actually make 148 run all the way. So I'm going to be real flexible as far as that goes, especially flexible for the people that have signed up for both, because there will be some things that you can do and they will apply to both of the courses. And so you might as well take advantage of that. All right, so I'm down here in this 128 program and in here, and I'm gonna, I already have a test.py. Let's see what's there. Oh, it's this. This is my test.py. Well, that's a nice test.py. Let me go back over here, and I'm going to copy this. Let's see if this works. Let's see if this works. I'm going to copy this. Copy. And I'm going to go over to my Visual Studio Code, and I'll get rid of all this. Delete, and I'm going to do a paste. Okay, so now I got some code here. And what's cool about Visual Studio Code is I can just press this button over here and it's going to run it. No, it's not going to run it. I press run and debug. And I pick a configuration here. Just the first one, Python configuration. And then it runs it down here. See, it runs it. And this is running it. Okay, here we go. You should click down here to make sure they're okay. Enter text to hash. Okay, I'm going to say text to hash. Enter. And then enter an algorithm. I think MD5 must already be in there. MD5.
there, and this is what comes out. So now, if all I store in my database is this, okay, so I store the MD5 hash of, let's say this is a password. Let's say that's the password. And I store this, and then next time the user logs in, I say, type in your password. Can I do? I think I can just do. I'm just gonna do py test.py. I think I can do that. Oh, here we are. Hash. So, oh, well, what's your password? And this is they type in the same thing, or they type in their password, and I'm doing an MD5, and lo and behold, it comes out this, which is exactly the same as this. And so I know, oh, the person must have typed in the right password. And there's no way that you can go from this back to this again. Well, you can, but it's, you know, some kind of NP complete problem that takes forever, and it's just computationally impractical. So, it works as a password. So that's a hash. Okay, so in this problem, we've got a MD5 hash, we've got SHA1 hash. Let's try SHA1. I'm gonna just do that again, and I'm gonna type a text to hash, and this time I'm gonna type SHA1. And this is a different hash. And what this problem is asking me to do is to add a third type. I guess that's a hash type. So let's go look at hashlib. Let's go look at the Python. What time is it? Look at the Python hashlib module. Let's see what's in there. Ooh, got plenty. Get plenty kind. Ooh, collision weakness. See, it's that has to do with when could be that, you know, text to hash is a password that maps into that hash string, but it could be there could be certain sets of strings or certain, you know, different kinds of passwords that all map into the same one, and then you may have a problem. You know, text to hash, you know, maps into that, so it passes. But then, you know, Charlie's pickup truck might also hash to the same thing for some random coincidence, and so that's what they talk about. That's what they're talking about, but it's so rare for that to happen that doesn't matter. Okay, so is there a list of them here? Blake 2. Where do I? Well, I don't really know, but let's go back here and fix this. To finish this assignment, this challenge. So we want to add SHA224. SHA224. Great. See, it knows. See, it has IntelliType or whatever, where it's because it knows it's Python. It knows it's Python because it's got the Python module. It's got the Python plugin. These are all the plugins, and it ends in py. So then it's smart, and it has all these. It's able to suggest to you what different valid correct possibilities there are for what you're typing in. And so this MD5 SH4. So I'm going to add. I'm just going to. I'm going to do this. I copy this, copy, and I'm going to go right
here and do a paste. And I want this to be back here. And this is going to be SHA224. And this is going to be 224. Yeah, that's what it is. So this should work now. Let's run it. I'm just going to do the P1, my PY1, and I'm going to say text to hash and ask me the out. Oh, I should say slash. Okay, SHA224 works. Uh-oh. Is that right? 224. Did I do the right thing? SHA224. That. Oh. Maybe it's not in here. It has to be in here. No, it didn't work. Run and debug. Here. Okay. Text to hash. SHA224. Oh, it worked. Why did it not work last time? I don't know. Let's see why. Text to hash SHA224. Well, I don't know why it didn't work before. But anyway, it works now. So we can just copy this. Copy. Copy. And paste it over here, I guess. Is that what we're doing? Oh, okay. Let's paste this here. See, there's the SHA224 now. And if we put well, let's see what this looks like. Oh, we have to put in SHA224 right here. Well, anyway, so that's pretty cool. I guess we could check to see if it's, so let me change this to text to hash and run that. And this should start with DD11 E88C. DD11 E88C. Yeah, so I believe it's the same. You know, another thing that's pretty cool is that you can put in breakpoints. So let's say I want to say, well, wait a second, I want to see what algorithm is right here. What's the value of this variable called algorithm? What's the value of that right here? So let me run this. And I'm going to go, thing pops up there. And I'm going to wait till it runs. And I'm going to say whatever, text to hash. And then it's going to say, enter the algorithm. And I'm going to say SHA1. And then it's going to stop. Stop right here. And then I can look over here and say, look at these variables. The variable algorithm is equal to SHA1. That's I just typed it in. And the variable text, which is this one up here, is equal to text to hash. That's what I typed in. See? And let me add another breakpoint right here. Can I do that? Oh, here. Okay. Now let's continue. I'm just going to click on this one, continue, F5, and then dig, it stops there. And then I can look and see algorithm is SHA1, output is, oh, we have now output. What is that output? Where's the thing I'm outputting? It should be, oh, it's, oh, wait. Look at that. Am I not seeing? Well, I don't know why I can't see the variable output. It should be the big long string. Let me run it. See if it runs. Okay, it prints out hash value. Okay, well, anyway, it's not the purpose of this class to cover breakpoints right now, but I'll have a class next. I will have a class. Let's see, I've moved my camera here. I'll have a class next week, and if you can think of anything that you'd like me to cover the last good class, please let me know. And if there are no questions, are there any questions? I will see you next week. Thanks for watching.